Okay, today we're going to dig into something that I think is a really new way to think about AI safety. It's called sort AI. And the big idea here is that to make our AI systems truly trustworthy, we've got to look way deeper than we currently are to find those hidden problems that, our standard tests just completely miss.
Look, we've all seen AI mess up, right? But what if I told you the most dangerous mistakes aren't the ones you actually see? They're the silent ones, the failures that are quietly building up under the surface, totally invisible to our tests, just waiting to cause a massive breakdown when we're least expecting it.
So to fight this stuff, a lot of us, of course, turn to things like RAG, Retrieval Augmented Generation. And the idea is pretty straightforward, right? You just ground the AI in a bunch of real-world documents to keep it honest, stop it from just making stuff up. And look, it's a huge step in the right direction, but it is absolutely not a magic bullet.
And that's because even with RAG, these really sneaky structural failures can creep in. You've got things like misgrounding. This is where the AI gets really clever and uses a correct piece of evidence to back up a totally wrong claim. Then there's retrieval collapse, where the system just gets stuck in a loop, pulling the same irrelevant, maybe even biased context over and over again. But honestly, the one that really gets me is deceptively stable loops. This is where the AI looks perfect. I mean, it's passing all the tests, but underneath, it's slowly, quietly drifting into a really unsafe state. And of course, you've always got the risk of bad actors poisoning your data. That's adversarial interaction.
So this begs a pretty big question, right? If your retriever seems to be working, and your generator seems to be working, why on earth is the whole system falling apart? Where is the error actually coming from?
Well, this image really nails the answer. On the left, that's how we like to think about these systems, like a neat, clean assembly line. One piece does its job, passes it to the next, simple. But the reality? That's on the right. It's a mess. It's not a straight line at all. It's this complex, tangled web where everything is affecting everything else, all at the same time, in ways we can barely predict.
And this really gets to the core of it all. The researchers behind this put it perfectly. They said, errors are often not attributable to a single module, but to latent interaction effects. So let's break that down. It means we're looking in the wrong place. The problem isn't one broken component. It's the hidden, invisible interactions between all the components. The whole structure is what's failing.
Okay, so the solution, a structural view. This is where Sort AI steps in. Think of it as a totally new set of glasses, a new lens that lets us finally see and diagnose the overall health of the entire system, instead of just poking at the individual pieces.
The key idea here is something they call structural drift. And the best way to think about it is like the alignment on your car. You get it aligned and it drives perfectly straight. But over months of driving, hitting little bumps, taking turns, it starts to slowly, so slowly you don't even notice, drift out of alignment. Until one day you realize you're constantly fighting the wheel just to stay in your lane. That, right there, is structural drift for an AI system.
And this image just illustrates that perfectly. That blue line, that's the safe path. That's the fixed point the system is supposed to always come back to. But look at the orange line. That's our deceptively stable system. At any single point in time, it looks pretty good. It's close to where it should be. But those tiny errors are adding up. And over time, it's drifting farther and farther away into a really dangerous place.
So let's compare these two states, because this is where the real danger becomes clear. A genuinely stable system, it's robust, it's self-correcting. Little errors happen and they just disappear. But a deceptively stable system is incredibly brittle. It looks fine, it looks fine, it looks fine, and then, boom, catastrophic failure out of nowhere. And it's because that hidden drift was accumulating the entire time.
So what does this mean for something like explainability? Well, for years, we've been obsessed with explaining individual tokens, right? We're trying to trace which exact word in the input caused which exact word in the output. But that's like trying to understand the Mona Lisa by analyzing a single brushstroke. It's pointless. What Sort AI is telling us is that we have to zoom out. We need to understand the whole painting, the system's overall geometry, its stable zones, its trajectories, basically the invisible physics that govern its behavior.
Okay, section 3, why this matters. And this is where it gets really interesting, because this isn't just about making RAG systems better. This whole structural viewpoint, it's like a universal language for AI safety. It applies way beyond just RAG. The really powerful thing here is that this basic structure, some process acting on some state, it's everywhere. It doesn't matter if we're talking about a language model spitting out text, a robot moving its arm, or even some wild future quantum computer.
The core principles of drift, stability, and these fixed points, they apply to all of them. It's a fundamental pattern.
And that leads to the ultimate payoff. What Sort AI gives us is a way to actually audit the deep structural integrity of any complex AI system. And here's the kicker. You can do it without needing to know every little secret of its proprietary architecture. It's a way to certify that a system is truly stable, not just pretending to be.
So if there is one crucial thing to take away from all this, it's this. The next big leap in AI safety is not going to be about chasing a few more percentage points on some benchmark. No. It's about figuring out how to measure and maintain the structural health of these incredibly complex systems we're building.
And that kind of leaves us with one last question to chew on. In this mad dash to build bigger and more powerful AI, are we actually measuring the things that truly matter for safety? Or are we just measuring what's easiest to see, what's easy to stick on a leaderboard? This whole structural view suggests we might need to start looking a whole lot deeper.